properties, specifically, why can we solve equations the way we do? And we're going to justify each of the steps when we solve equations. And so in section 1.3, you're going to notice there are some charts that go over the different properties. And so we're going to look at those right now, and then we're going to look at a few example problems. So the first one is the reflexive property. The reflexive property states that any quality is equal to itself. So for any number A equals A. Okay, reflexive property, this is what you need to remember with the reflexive property. Reflexive property deals with 1. Symmetric, on the other hand, deals with 2. And so the symmetric property states that if A equals B, then B equals A. So in this case, if 8 equals 2x plus 6, then 2x plus 6 equals 8. We have two things. We have 1 here, 2 here. Transitive deals with 3. Okay, transitive states if A equals B and B equals C, then A equals C. So basically transitive, if you notice this, 6 plus 9 equals 3x plus 12. 3x plus 12 equals 15. So you can conclude that 6x plus 9 equals 15. Basically with transitive, you're cutting out the middle. Okay, because the 3 plus 12 you know is the same, so if you take out that and take out that, that leaves you with the 6 plus 9 and the 15. Now this is the way you distinguish between the two. RST in alphabetical order, 1, 2, 3. Okay. RST, 1, 2, 3. Reflexive, symmetric, transitive, 1, 2, 3. Very last one is substitution. Basically substitution in this case, if n equals 11, then 4n equals 4 times 11. So in place of n, I've now put in the number 11. Okay, so more properties. Okay, so you should see more of these. More of these are listed on page 16 and 17. Additive identity basically means you can add 0 to any number and get the number itself. And then we have the additive inverse. Notice when we add the additive inverse, I get 0. What's another name for additive inverse? Opposite. Basically, it's a number and its opposite. Multiplicative identity. Any number times 1 is the number itself. Multiplicative property of 0 states you multiply anything by 0, you get 0. And last but not least, the multiplicative inverse. Basically, that means if I have A over B, and I take that times B over A, that will equal 1. What's another name for multiplicative inverse? Reciprocal. So basically, multiplicative inverse is a fancy word, fancy term for reciprocal. Additive inverse is a fancy term for opposite. It just sounds more academic. Oh, we're going to add the additive inverse. Okay? Or we're going to multiply by the multiplicative inverse. So anyway, let's go ahead and look at the following. Alrighty. Evaluate 7 times 4 minus 3 minus 1 plus 5 times 1 over 5. And the instructions are to name the property used in each step. So this is what I started with. So I don't have a step right here. Oops. So I don't have a step right here. That's where I started with. Now what I need to do is compare the purple to the blue step. So let's look left to right from here to here and see what's changed. I have 7 times 1 on the top. I have 7 below. Minus 1, plus 5 times 1/5. So the only thing different is this to this. So let's see. 7 times 1 equals 7. So what property is that? Yep, got it?
Multiplicative identity.
Multiplicative identity. So this would be the multiplicative identity. So now what I'm going to do is I'm going to go green to aqua. Let's see. The 7 is the same, minus is the same, 1 is the same, plus is the same. Oh, I notice that 5 times 1/5 now becomes 1. So what is this? Let's think about 5 and 1/5. What do you know about those two numbers? They're reciprocals. So let's go to that reciprocal. The fancy word for reciprocal is what? Multiplicative inverse. So that's the multiplicative inverse. Okay, let's go to the orange. So here's orange. So let's look. 7 compared to 6. Uh-oh. So let me look up above. Oh, well, I know that 7 minus 1 equals 6. 7 minus 1 equals 6. What do you think this one is? Because that's what we're doing here. Ideas? Is it reflexive? No. Symmetric? No. Transitive? No. Substitution? Actually, this one is substitution. Okay. Why is it substitution? It is substitution because you have substituted 6 in for 7 minus 1. So basically, if you do something like this, that's probably what it's going to be, substitution. And the very last one. Let's look. Oh, 7. I get that from 6 plus 1. So what's that one going to be? Substitution. Because what have you substituted?
6 plus 1 for 7.
6 plus 1 for 7. Okay, let's look at the next one. So, name of the property used in each step. Now, for those of you that things are still a little foggy, hopefully we'll go through enough examples so they won't be as bad. So let's go ahead and look. Here's my starting line right here. The purple is my starting. So now I'm going to compare to the next line. So let's see. The 2 times 3 is the same. The plus sign is the same. Oh, here's the difference. 4 times 2, 8. What's that going to be?
Substitution.
Substitution, because we know that 4 times 2 is 8. Okay, let's go green to aqua. This step right here. What's different here? The 8 minus 8 is 0.
Additive
8 minus 8 is 0.
Oh, that's
additive inverse.
8 and negative 8 are what? Opposites. So this is that opposite one, so we have to think of the academic way to say opposite, and that is the additive inverse. So this is the thing. If you're wondering, is it substitution or is it one of those other ones? If it's 0 when you add, it's the other one. If it's 1 when you multiply, it's the other one. You won't use substitution on those. Okay, let's look at the next one. Let's compare. What have we done here? Yep, 2 times 3 is 6. So what is that one going to be? Substitution, because it's not the 0 or the 1. And the very last one. Let's think about that. 6 plus 0. We got a 0 in there. Look again. What's that one going to be? Additive identity. Very good. Now, do I expect you to memorize these? No. Okay, so come test time, what I'm probably going to do is have a sheet of paper with these properties for you. And then what you will do is you will have to identify what property is which. Okay, I don't expect you to memorize additive identity, additive inverse, and that. I just expect you to be able to apply that. So let's go ahead and look at this next one. So here's my starting line. Let's look at what I've done different here. What have you done different? 15 divided by 3 is 5. What is that? Substitution. Okay, so let's look at the next step. Let's look at the aqua step here. What's different? 5 minus 5? 0. What's that one? Additive inverse. Good. Okay. Let's look at this step. What have we done? 7 times 1/7 is 1. Oh, so that's one of those ones. We got 1. What's this one? Multiplicative what? Inverse. Okay, let's look at the red step. 6 times 0 is 0. What's that one?
Oh, no, it's
Multiplicative
additive.
property of zero.
Additive.
Multiplicative property of 0. So I'm going to abbreviate since that's a long one. Multiplicative property of 0. Okay, and then last but not least, what's 1 plus 0 equals 1?
Additive.
Which one is that one? The additive, oops, identity. Okay, looks like I need to go get my power tour. So the additive identity. Questions on those? Think you can handle those? Let's look at the second part of your assignment then. Second part of your assignment deals with the commutative and the associative property. Commutative, what's the root word of commutative? Commute. So, what does it mean when you commute somewhere?
To travel.
You travel. So every day, you guys wake up and you're at home, right? And then you get up, at least on Monday through Friday, and you go where? School. Then we get done with school, we're done at the end of the day, and then where do we go? Home. So when we think about commutative, we think that we are commuting. Commute. So when I think about that, I go from home to school, and then I go from school to home. That's the commutative property. Two things. So in this case, 4 plus 8. Home to school equals school to home. Home to school equals school to home. Two things. Associative, on the other hand, deals with 3. Okay. So in this case, notice this. 3 plus 5 plus 7. Okay, now it's 3 plus 5 plus 7, but they've been associated in a different way. So let's go ahead and look at a few examples here. Okay, it says Eric makes a list of items that he needs to buy for a party and their costs. Find the total costs of these items. So what am I going to do with these? Add them up, and that's it. Okay, so we have $6.75, and they do this using properties and things like that. I don't care as long as you can solve the problem. I'm not going to make you use those different properties. So all I'm going to do is add all these up. It's a basic addition problem. Okay? So if I add all those up, let's see what we get. 0 carry 1. 15 carry 1. What do you get? 14 carry 1. So total price, $64.50. Okay, so that's just more problem solving. Questions? Here's your assignment for tomorrow, 19 through 20, 10 through 48, the evens. Okay, quiz tomorrow as well.